Hoffman.
Hey friends, I'm Nikolai.
Hi, I'm Mustafa Turaman.
Hi, I'm Tanya Janka.
Hello.
And I'm excited to be the speaker at Azure Summit 2021.
It's a fantastic event that will be 11 days live streaming,
Where more than 100 speakers from all over the world.
I'm excited to speak at Azure Summit about Power BI and Synapse Analytics.
And I'm going to talk about security.
And also a Microsoft MVP for Azure.
I'm speaking at Cloud Summit about automated release of .NET application.
And the best part is that this is a free event.
Come join me live at Learn TV on September 17th.
Come join me live on Learn TV on September 14th.
Come join me on Learn TV on the 14th of September this year.
A bunch of other Microsoft and community speakers.
So if you want to learn how to secure Azure, come to my talk.
join us. It will be a lot of fun.
See you there.
See you there.
See you there.
See you there.
All right, welcome everyone to day 3 of Cloud Summit 2021. I'm your host, Stephen Simon, and welcome back. What an absolutely amazing first 2 days we have had at this event, reaching more than 40,000 unique audiences across all our platform. And when I say all our platform, we are streaming this Cloud Summit 2021 at Azure Summit.live website. We are streaming on Learn TV. We are streaming on Microsoft Developers YouTube channel and a bunch of more destinations. So for people who are joining us for the very first time, this is Cloud Summit 2021 focused just on Azure with over 150 speakers and 113 sessions. There is 11 days of live streaming just focused on Azure. You'll get to learn the entire ecosystem of Azure, from the people who are building Azure to the people who are working on Azure, and from the people who are actually learning Azure. So I'm really excited for this day 3 part 1. So as always, I've been looking in the comments from past 2 days. You all have been very kind to each other, and that's what I expect to be continued. Please be kind to everyone. Follow the code of conduct. And yeah, having said that, when it comes to the comment section, so we always have a contest going on. So there are usually 3 contests. The first contest is the live comment contest. So whenever you drop any question to the speaker or share your thoughts in the comment, please use #CloudSummit hashtag, and towards the end of the day, also towards the end of the this first part, we're gonna pick the winners. Also, we have the contest going on Twitter and on LinkedIn. So take a screen grab or take a selfie of you watching this Cloud Summit. Tag us at Cloud Summit Live. Use the hashtag Cloud Summit and tag us both on LinkedIn and on Twitter, and we will pick winners from both the destinations. So again, welcome back. This is day 3, September 15 of Cloud Summit 2021. And having said that, I'm really excited for the very first session of the day, because it's going to be on Azure Custom Vision. The other day we had Prashant talking about the entire ecosystem of Microsoft Azure AI and machine learning, cognitive services. And today we have Ambarish, who's going to talk about bees health detection using Azure Custom Vision Services. I personally love Azure Custom Cognitive Services, the entire package that they have, and that you don't have to be a very hardcore developer to go and get started. So without any further ado, let's invite our very first speaker of the day, Ambarish, who's a NASA citizen scientist, TCS Data and Analytics Practice Lead. So let's welcome our very first speaker of the day 3, Cloud Summit 2021. Welcome, Ambarish. Welcome to the Cloud Summit 2021.
Yes, thank you so much. Thank you so much for allowing me to participate in it. It is a very fascinating event. So without further ado, let me start my session. So this is about a very interesting thing. This is about bees link detection using Azure Custom Vision Services. So let's jump in and I'll give the motivation behind it. So what is the motivation of doing this? We might know that every third bite of food relies on pollination. But honey hive bee losses are quite prevalent due to disease. But the indication of hive strength, what is the health of the bees, is very time consuming and disruptive to the bees' workflow and hive in general. So by investigating the bees that leave the hive, we gain a more complete understanding of the hive itself. For example, an unhealthy hive infected with the varroa mites will have bees with deformed wings or mites on their backs. These characteristics can be observed without opening the hive. So that is the motivation. So it is an ecological problem, and we are trying to solve it through image classification. So what are we trying to do? We are aiming to detect healthy and various types of disease beings, disease and ant problems, the varroa and hive disease with the help of Azure Computer Vision Service. So where do I find the data? The data, what we have done is that I have taken a data set which is from Tangle, and I have made a very small data set of it. So these are the links that are there, and we can go into the Tangle link as well. If you just use this. So if I go into this, so this is the actual data set. It is quite large. It is around 54.74 MB. But what I have done is that I've gone ahead and made every data set, which is a subset of that. It is all in Tangle. It is free, so you can download it and see it. So intention is to detect healthy and various types of disease. So what are the steps? So I'll just give you the steps here, and then we walk through the example and how we have done it. So first is we create a custom vision resource. And then we create a custom vision AI project, and then we add images to the project, and we train on the images and create a model. So these are only factual things. What we do is that we go into the Azure and we'll see. So this is we are in customvision.ai. So I have already done the projects myself because training takes a lot of time. But if you are going to do it yourself, so that's actually very easy. You can do a create project. You can say these. Since I've got a these project, maybe these two. These add some description, and you create the resource. So here you can create one resource, whatever resource you want. You can create one resource. You can choose your subscription. You can choose your resource group. This is cognitive services. It's a location and a pricing. So this is how you would create a resource. And then what you would do is that you would choose a project type, whether it's a classification or an object detection. So in this case, since we are classifying the bees, we should be choosing classification and not object detection. Here, we will be choosing the classification type. So you can go here and see what is the meaning of it. But basically what it means that for one image, there is only a single label. It is not a multi-level problem. Meaning, if it is an ant problem having some ant problems, then it is an image of ant problems. If it is an image of, say, varroa hive bites, then it is an image of ant. If it is healthy, it is healthy. So it is a single tag for image. And there are certain domains here, we make it general, and then we can create a project. I will not do it because I have already done this project, and so this is the these project out here. So what are we doing is that then what we do is that we add images. So how we add images, I have already added the images, but I'll show you of how you can add images. You can add these images by say, going to add images, you can go to here, maybe say suppose I'm doing this healthy and problems. So I'll choose here, I'll say open, and then what I'll do is that I'll add my tag. So here I'm choosing the images and I'm putting a tag and then I'll upload the images. So what would happen, you see here I've already done this because the training and the uploading takes time. So I have add problems, which is have all these that I have uploaded out. Similarly, I have uploaded some LDBs. So these are the LDBs which are down here. Similarly, I have arrow height features which are here. So it is a key class problem. So there are 3 types of labels here. And after I have done, what I do is that I go ahead and train this. So training, I can choose quick training. So this trains the image and it takes a lot of time. So I've already done it. So it's already trained. So the training, what will happen is that, so as Sam was saying, so this is a great thing. So previously, if you were a researcher or a deep learning data scientist, what would happen is that you have to write all these algorithms, all these models like ResNet, EfficientNet, and all these complicated models. You have to understand the structure, but here you do not have to do anything. Just you have to know your domain. So the domain here was these. You have to know the label. Somebody will label it for you. So if you're a domain expert, this is great. So it helps you that once you label it properly. So now is these that we are talking. You can talk about more serious problem like, say suppose if you're in a manufacturing industry or an utilities industry, you will have some say rods or assets where there are some cracks. You can do these type of things. You can label it some having some crack type 1, crack type 2, crack type 3, and you can differentiate between them. So that becomes very easy. So for a domain expert, it's a great thing that you see. And then you train it. Once you train it, it's already trained, and then you can do quick tests. So what would happen is that after it has trained, it would use this model so that you can use it for training, for testing. So what I do is that I browse to a local file out here. So here I have, so suppose I test it. So I choose this image and I go here and I see the tags which is coming up. So it says that it's a arrow height V2 and it's an healthy and problem. So actually it's giving that this one is the one, it's the arrow height V2. But to know whether we have done it correctly or not, so what we'll do is that we'll see the actual data. So what did we choose? We chose this guy, so it is 040314. So I have the data actually with me from the data set 040314. So if I just do a filter, 040314. Okay. So it is a arrow height V2. So it is giving like this arrow height V2. So this is the one. So it is doing it correctly. So we will see of how we can do. So this is from the E1. So what would happen if I try to use it in a program? So what would happen is that this is a project out here. And then what I will do is that I will go to the project and there is a project ID out here. So this is important and this is the project ID is important, the key is important and endpoint is important. Now once I have trained, so say suppose now you have spent a lot of time in labeling and you have trained the model. Now what you do is that you want to use it in your own application. So what I did was that I am using this endpoint which is there and the key, and I'm using the project ID as an API in an external program. So what I did was that I went around and created an application, a Node.js application. So here there is a blog also I've written for this. I'll share all these links with you. So here what I have done is that I've created a Node application. So this Node application I've created, and it is installing. We will install all these libraries, the cognitive services, custom vision training, the cognitive services, custom vision prediction. And then we import these libraries, and then we have the training API, the prediction API, and then we have the route where the data is kept. We have the prediction key, endpoint, the iteration name, and the project ID. Note what is important: prediction key, endpoint, and the project ID. Otherwise, all these things are all standard things, but what will be unique is this. So this is required for predicting and for authentication. So once, and you can get all these things from your project. So project ID, key, and endpoint. So I went around and did all these things. All the code is here. So then what I do is that I pass on an image like 040314. Or I can pass in 030471 also. 471, 030471, 030. And what would happen is that I'm going to use this for predicting. So if you see, these things are for prediction, and this is the data that I am passing in, and I am using it for predicting. And then I am using it as to calculate the probability. So if I just run it, so if I say this, so it is giving AND problems. So this thing over here, 030471, it is having AND problem. Let's see whether we have done it correctly. If I go into this side, 030471. You see, it is AND problems. So I have predicted it correctly. It is showing me AND problems here. So this is how, in a very simple way, if you're a domain expert, you can train it, and then you can give it to the developers. And even if you're a developer, also you can do it if you have some amount of domain knowledge for labeling and for doing all these things. So it is very, very seamless and easy to solve very complex problems and to solve very problems that is affecting the world with Azure Custom Vision Service. So that was the whole intention of showing this demo. So I'll see if there are any questions.
So are we done with the presentation, Ambarish?
Yes.
Okay, that's great. So that was great. I mean, you're uploading some pictures on the Azure Cognitive Services, right? Then not even writing a single line of code, and then just training it. A quick question. I mean, how many ideally pictures I should add to train my model so that it works?
Yes, that's a great question. That's a great question. Usually, people they say that it's around 50, but I would say load as many as possible. And put it what they say is that, which is very correct. So if you have an object in one position, you try to have object in another position, so that you have a lot of variation in the image, so that it helps the training much more easier.
Okay.
So say suppose example, you have a dog and you have the dog facing towards the right, so that's one image. Preferably, you should not have the same dog picture 1,000 times. Rather, you should have some other dog which is facing to the left. So that data variation, if it is there, that would be good. So 50 is the minimum. I have loaded 100, and that's about it. So it was a great thing. So another thing that I did, I used it for eye images. For eye images to detect retina problems, diabetic retinopathy. It is not that great because you have to do some pre-processing before you load the images.
All right.
So,
yeah, go ahead.
Yeah, so yes, so why sometimes that image what we are giving it to them, the model cannot really do it perfectly. So what happens is that if you do some pre-processing and do those things, then the model is able to do it properly. Ultimately, under the hood, what it is doing, it is using some deep learning models. So if you are a data scientist or a deep learning researcher, if you suppose you didn't have these type of wonderful services, you have to code it yourself. So that's how it's being under the hood. And for a deep learning image, input should be very good. Here the input was great, and we got around, say, that's a great thing that I can show you. Here, here the predictions on these images, performance on these images was around 100. You won't get 100% actually. So this was great, but usually it's not like that. So you have to do some more pre-processing on these images. But this was a great set of images, and we ran all these code, and it turned out very nice and gave very good results. So it was, when we ran it with ant problems, it gave me a 97%, and actually it was 97%. So how we can use it in practice is that is you bring in quality images, and then you will get better results. I see there is one good question. The more data set quality, the more best results. Yes. Is there any possibility of wrong conclusion? Yes, absolutely. Because certain times what would happen, the model may not be able to do it properly. And then what you would do is that, so this is something which is very custom. Then what you would do is that this custom vision service is not helping you out. So what you will do is that you will code on your own. You will do a lot of pre-processing. You will fire up your Python SDK, and then you will write your own code, and you will deploy Azure in it and put it in production. So this is the very first step. So if you're approaching a problem, this might be a great step. It works out, it's fine, and it is a person who is a developer but does not have a lot of deep learning, machine learning experience. It becomes easy for them. But if suppose it's very custom, it's not really typing out, then you go for something hand coding with Python.
All right, that definitely makes sense. That was very detailed. I think you took it. The question from the comments. I have a couple of questions, Ambarish. We still have 5 minutes before we move to the next session. The very first one is the computation, right? Do I need to actually go ahead and create a computation dedicatedly before I start it,
No.
or I get it from the cognitive service? How does that work?
Yes. Cognitive services is doing it on its own. So that's a great thing. So that you are, meaning you don't have to do anything. So that's it.
Okay.
So very frictionless. It's very developer friendly.
Yeah, that is right. So I don't have to worry about the computation, the all the hardwares and all, right? What are the specifications I need? That's perfect. Also, quick question, Ambarish. Now, once I've trained my machine learning model, right, I figure out that hey, it is working fine, but maybe I need to add some more maybe I've got some new version of bees, right? So maybe I need to upgrade my machine learning
Yes.
model. So do I
Yes.
have to again go back and upload the pictures and retrain my entire machine
Yes.
learning model, or if there's any
Yes.
other way out?
Yes, I think that's the way to do. Is that you go ahead and add those images, and I will see the more variety of images you put,
Mhm.
the more your model would be there, and you retrain it once more. So that's great. So, and then you get another version of the model, and then you use that model to use in the API and in your application.
All right, that's great. So you're telling me once the machine learning model is trained, I get these endpoints like APIs, and I can use it
Yes.
in any of the
Yes.
other application that I have. May it be a web application, a mobile application, maybe I think Power Platform. I think in Power Platform ecosystem they already have inbuilt this cognitive services, right?
Might
So
be. I do not know
yeah,
whether it does, but
yeah.
for you is and for a developer it doesn't matter. It's a REST endpoint, so anybody
Mhm.
can use it. It can be from a Go application, it can be from a Python, it can be Java, it can be
Mhm.
even this. You can do it from CRM also, right? Microsoft CRM or Microsoft Biz
Mhm.
apps. So that's great actually.
That's
And
amazing. That's amazing. I think it is something that people should definitely go and check it out. So, Ambarish, quick question before it's now. Suppose I don't have an Azure subscription, right? And I want to go ahead and use the cognitive services. I'm not a Microsoft partner. I'm not a Microsoft MVP. My company is not having this Azure subscription. Is there any way I can go and get started with some free subscription or tiers?
yes, absolutely. And actually, you know what? That was my position. I did not. I am not. In, now I am having some subscription, but previously I did not have anything. So it's
Mhm.
actually, Azure is that part is free. Somehow I'm using this subscription. It is not allowing me to do that M0 free tier. So there is a
Mhm.
free tier there. So if you have a pay as you go or a free subscription, please go ahead and try it. It is a free tier and it doesn't cost much, even if you are trying out maybe pay as you go. So I would suggest that if you have some fun pictures, say Simpsons data set, like Simpsons, all these characters. So you can take from Kaggle and you upload it. It's maybe 100 pictures and all these things, and then you on your own can do a machine learning application and create a cool web app and expose it and you can brag about it. Or you can do something more interesting like some say I would say cracks in metal, cracks in say pipes, which is like a
Mhm.
manufacturing utilities kind of thing. Right? You can try that and see without employing data scientists, senior data scientists, and all these fancy maths. Can that solve? Maybe it might solve. So your innovation capability increases. This, as your cognitive services, it's an ability to innovate at a great length. So that was amazing.
All right, so that's perfect, Ambarish. I think you did answer my question that, hey, there's some free tiers. Go ahead and get started with this free subscription that Azure provides. I think it's for, I just checked it. I think it's for 30 days, right? So it should be good enough for you and your team to
Yes, yes.
to test it and understand whether you should go for it or not. Ideally, you would go for it once you try it after looking at your session. So that was an absolutely amazing session, Ambarish, on Azure Custom Vision Service. Any final thing you want to plug in before we move to the next session?
Yes, so there is a blog out here. I don't know where I can put in the comments. Maybe I'll put into
You can give in the
in the
private chat.
private
I'll get
chat,
it.
private
Yeah.
chat, and this is the blog out here. And the great thing was that this blog post won one of the blogging contests of Azure, so people liked it, and it is very detailed. It has got the source code, it has got the step by step of how I did it. So if and it has got the public data set also. So please go ahead and try it on your own. That is fine. And another thing is, I just want to show you is that I do a lot of YouTubing and sort of things, which I will also share in my previous in the chat. Is that people I just get that started. So if anybody is interested in machine learning, deep learning, and Azure ML and microservices, please go ahead and have a look at the channel. I keep on updating, so it's all community work.
That's great. So YouTube channel and all the links I've dropped in the comments. Everyone watching, please go ahead and check it out. Ambarish content. Once again, Ambarish, thank you so much for accepting the invitation. We really appreciate it. I know it's evening time here in India, so we like to go out and hang out with your friends and families. So thank you so much. We would love to have you back whenever we do. So we do these events like almost every day. We do live shows and conferences like almost every other day. So yeah, we'd love to host you back whenever you're available. Thank you so much. And yeah, have a nice Wednesday.
Thank you so much, Simon. And the questions were awesome from the audience and from you. Absolute pleasure in giving this session.
Thank you. Thank you so much, Tara.
Thank
Bye.
you. Bye-bye.
All right, with that, an absolute amazing session by Ambarish, we now take a break and move to the next session, that is a bot from idea to deployment. And here's a quick thing, right? So everyone watching today's session, I see some of our partners, Heiko. Heiko is an absolutely amazing person. Everyone who's watching, thank you so much, Heiko. Heiko's organization and team is one of our partners for this event. So really want to give a shout out to them. So everyone who's watching this live stream, right, please feel free to go ahead and ask a question in the comments. I'm really sorry for a quick some audio issues in the past session, but here's a little more update. This session and the following session is actually recorded, so I'm not sure if we will be able to take your questions, but yeah, the next session is by Sammy. Sammy is a Microsoft AI MVP, and he's going to talk about on how you can actually build bot from an idea to the deployment. So I'm really excited for that. And without any further ado, let's go ahead and watch this session by Sammy.
For joining me at the Cloud Summit today. Looking forward today to talk about a bot from ID to production. So today we'll be discussing 3 different topics. How are we getting to the ID of what kind of bot do we want to build? What infrastructure do we need and how can we convert it into code? And then of course, the most important part, the logic of your chatbot. And then at the end, how can we build the full CI/CD flow on that? My name is Sammy. I'm a CTO at Arinti, which is a Microsoft partner here in Belgium. And I'm a Microsoft AI MVP for already 2 years. And I'm also part of the global AI community as a board member. So let's kick off this session with the first topic of the day, and that is DID. So with my own firm, what we do is always start with a workshop at our customer. Why? Because our customers might have specific ideas about what they want to do with a chatbot, but for us, it's very important to make, first of all, a bunch of things clear to them. Many do not fully understand exactly what a chatbot actually does, how it works in the back, and we find it very important that they understand that, because it gives them a better idea of what is possible and what is not possible. In the meanwhile, we explain them all the things that can go bad and these pitfalls of projects that have happened over the last 5 years that we've been doing. We need to explain them that chatbots are mostly built to lessen the work done by your customer care center so that they can focus on the most important part of their job or focus on more important parts or more difficult problems that are there in the company. We will ask them questions like, what questions do you get the most and what actions do you need to take more often? And then also take in mind that they don't start building a process for something that happens only once in a while, because it will take a lot of time to build with a short return on invest. It's very important to set expectations. A chatbot is a piece of software and it needs to keep on living. It's a never-ending product because you always need to make it better. So it's very important to work on an ID that is in an agile way. A chatbot needs regular deliveries of small extra features. And then very important, and that's something that you need to make clear from the beginning of your chatbot, is make sure your customers know exactly what you need to expect. What does that mean? Well, in the first messages, already tell them, like, this is what I can do, and this is what I can help you with. Now, after you've set up your ideas concerning what you want to do, now the next steps will be, how do you want to interact with your customers? Do you want to be extra polite to them and always talk to, hey sir, here, hi madam, or you just, hey you, how are you doing, being very casual? It's something you put in before you even start building your chatbots. We work together with the UX experts to be able to even draw out specific dialogues already. So it's been configured and drawn out what it will look like. And from there onwards, we can start developing the chatbots. So with other words, everything has been drawn out and written out what exactly the chatbot will do or say. And from there onwards, we can start developing and training our chatbot. So now we have our full ID, what we want to build. We know what the scope are. The scope is perfectly defined. Now we'll need to go into the next step. We know as an architect, solution architect, you know what services you will need on the Azure platform. Now let's start on building that. And that brings us to the second part of the session. Very important part, and it's infrastructure. Now we hear more and more about infrastructure as code. Now I'm a big fan of bicep code. Before we had ARM, which was okay to build infrastructure as code, but it was not always very readable. Of course, we also have Terraform, which is cloud independent. But since I'm mostly putting my focus on the Microsoft platform, well, I'm very happy with the code that the new environment that Microsoft created, which was called Bicep. So infrastructure as code, very handy, especially if you have an environment, for example, that gets, you have a lot of issues, then it's easily to spin up a new environment because everything is already in code. Same for all your apps and so on. In DevOps, we can fully have release cycles and manage it so that works perfectly. Now, for our bot infrastructure, we need to have a specific architecture, of course. This is a simple infrastructure design that I drew. The Bicep code, we will discuss that in a bit, is also available on my GitHub, github.com/Sammy Deprez/bicep templates, and there you will find bots also. So what's the code behind a chatbot? Well, it all starts with the logic of the chatbot, and that's all saved within this web app, which is of course running on app service plan. From there onwards, well, we'll need to do communication with, for example, Lewis to be able to understand what the human is saying, what the humans are saying. So data will be sent up and down to cognitive services language understanding. Now, from there onwards, we of course need to be able to save what has been saying. Since the chatbot is stateless, well, we still need to somehow keep track and being able to return, for example, what the variables were that were saved. So that will be all saved in our Cosmos database, which will be purely used for conversation state storage. Now, of course, within chatbots, we also have Q&A Maker to make a knowledge base which can easily be queried by questions and answers. Well, for that, we need another web app, which is the Q&A API, linked to the Cognitive Service Q&A Maker and the Azure Cognitive Search, where actually the Q&A knowledge bases are saved in. Now, this is all on the back end. Now we also have our front end of the bot, which is this part, the right side here. And that first part is the bot channel registration. The bot channel registration is the front entrance to your bot. So it will make sure that there's communication from a web chat, from Facebook, from WeChat, and many Skype, Teams, or whatever channel that you're using. It all starts here. So there's a secure communication line between these two elements, between the web app and the bot channel. The bot channel registration can also be defined to be able to handle speech, and that's also being able to be configured in there. So therefore we also put the line here to cognitive services to the speech service. Here on the top we also see an Azure function, and that I always use for my authentication method for web chat. So that way we don't need to put a direct line secret into our web page where the chatbot is running in. It means we will do a call to the Azure function first to return the token, and then communication can happen between the web chat, which will communicate through the bot channel registration to the web app. And then of course to finish it up, we have our key vault to just keep track of all the secure passwords or keys that are needed. For example, our direct line secret or app ID or app secret that is needed also for the communication between these two. So let's have a quick look between on the bicep code how that looks like. All right. So if you go to my GitHub repository, you will notice this. Be better. Cool. So you will notice this element here, and I need to move my face to another place so you can see it better. The code, it always starts from a main.bicep. If you go to the main page of the bicep template, you will also find the way how to deploy the code. So you have this can be done through the CLI on your own local computer before you even push it into DevOps. Now let's go back. So you see here that I call main.bicep. If we go to main.bicep, the nice thing about bicep is that you can work with modules. So I've already written a bunch of smaller modules to automate certain things. So first of all, I set some parameters that I can also give in from my own environment if I don't give them in. So with the CLI, if I don't give the location, I can still override the location, environment, project name, admin user ID, and so on. Now with the admin user ID, it's the user ID that I'm defining. That's mostly the object ID of my personal account on Azure, so I have access to my key vault. Then I have my application ID and application secret. That's what I need to define, well, to actually create in my Azure Active Directory as an app registration. This app registration will be used for the communication between your bot channel registration and your bot logic. From there onwards, we have a bunch of services that we need. As you might notice, I prefer to use decent naming conventions, so I took over the Azure naming conventions, and each time we add the project name and the environment to the names. So we have a key vault, the app service plan, we have the app service where the bot is running on, the function to get the direct line token. We add some application insights for logging. We have a Cosmos DB. Then we have Lewis authoring and Lewis predicting. We have our bot service, which is the channel registration. We add the logic also in case we would like to use it, and later on the name of our Q&A and the name of our bot. This is the bot that will also, the bot name that actually is going to be used in the environments too. So what I added here is a little script, which this is still not correct yet. This bot name should still be a variable that I can also give into the CLI script. So then we have a bot endpoint. This is based on the app service name that we created our app on. I try to tag my services with a small description, what it's about, and then what environment it is doing. And from there onwards, we're going to call multiple modules. And so the first one here is the module key vault. Then the next one is a module I wrote, key vault secret. Let me open it to actually add a secret into the key vault. So notice here I make the key vault, so I have my module kv, and from there onwards I can use kv outputs.name. And so I use the key vault name to add the secret, which is called bot app ID, with the secret value application ID. And this application ID is what I defined here. So let me go back to the modules, and there you see the resource that we're calling, the key vault name, the secret value. And what I'm returning is just the secret name, just to be able to add something. Now let's go back to our main. So from there onwards, I also add my bot app secrets. I create a server form, which is actually our app service plan. Then I create the websites, which is then again is the app where the bot is going to run, the logic of it. And notice here again, we have ASP, and I'm using here ASP outputs.id. So I'm giving the ID of this created server form to how to create the web app. From here onwards, I adding security. Well, I'm giving my web app permission to read my key vault. So here I use the app outputs.identity. So in this module, I'm creating also system identity for my web app, and I can go on. Then I create, do the same thing for my functions. I create my function here. I create a Cosmos DB. In the key vault, I add my Cosmos primary key. I create my application insights. Then I create my Lewis. Then my bot service, where I'm going to configure it with my application ID, the bot endpoint. So this is the messaging endpoint that we defined here on the top of the script. So we see here, this is our bot endpoint. Let's go back. We give some details about the application insights. And then once that is created, we get returned the bot direct line secret, which we're also saving into our key vault. Then after that, we configure our app settings with a bunch of stuff like our Microsoft App ID, app passwords. So this is needed to be able to communicate, to have a communication between the bot registration channel and the bot logic. So these details are needed in your app settings. I do the same things for our function, where I define the direct line secret, where I do not enter the value just like that, but I define it by telling it where in the key vault it is saved. That's also why, as well as the web app, as the Azure function needs permission to read the key vault. Again, that's a secure way, and you don't need to save any passwords in your code. And then we create our Q&A. Again, we say on which server farm it needs to run, so which web app. So we don't need multiple web apps. If you create Q&A maker manually in the Azure services, it will create a separate web app, which also means it will duplicate your cost for running your bot, because you need two app service plans then. By doing it manually, you can define beforehand already, this is the app service plan that I want to use. And that's it. And then we have a whole setup, and if we execute that, it nicely generates all the resources that you need. Now these scripts that I will open here again, this AZ deployment group create, this will create a resource group on your subscription, and at the end will create all the resources that are needed. It's also possible to create it on, you define already the, In this case, we defined already what the resource group is going to be, which can also create these scripts on a subscription level. And then you can run and create the resource groups manually in case you want to make, for example, a resource group specifically for networking. In this case, we didn't configure any VNet configuration, but it is possible. It would be nice if those resources maybe are in a different resource group, so you can keep networking and application separately. But that depends all on what your governance is on Azure and how you want to handle it. So let's go back now. We've seen all the parts now for Bicep, what is needed. Next step is now the code. So let's have a look on that. So that brings us to the last phase of the project, and that's of course, the biggest part of the project, that's building the code for your chatbot. So that brings us immediately to Bot Framework Composer, which I'm not gonna open up and show you around in it because that's not the purpose of this project, of this session, but we'll go straight into DevOps. So let's go here to my DevOps environment. All right. So what you see here is a project called Chatbot Robin. And on the left side, we click here on repos and then files. Now what you see here is the first part is here, which is called Robin. And Robin is actually the folder which is generated by Bot Framework Composer with all the details inside. I did not change anything to that, and I just add changes of my bot purely in there. Another part I have is my build template, and this is all defined by extra code that is actually from a part of the Microsoft Docs. So there's a specific article about setup continuous integration and continuous delivery for a Composer bot. It's still in preview, and it's something we are personally working on as a company also to still improve, because we still see some missing items, and we'll go over that in a second. So they explain it quite easily, all the steps that you need to take. It's all based on one YAML script that you need to take into your pipeline, and it will call different ones. So let's have a quick look on that. If we open our YAML script, to the first one, build and deploy. All right, so we set up a couple of keys, variables that we're defining, and from there onwards we will do install prerequisites, build and deploy models, and build and deploy .NET web app. So let's have a quick look in each of them. So we'll start at the prereqs. So in the prereqs, we're just installing nodes using the Bot Framework CLI, so we can actually trigger, for example, a training script of Lewis or a Q&A maker, and then we just configure what .NET Core version we want to use. Let's go to deploy the models. So again, we set some parameters. We configure our working folders, but then here, most importantly, training or language understanding models. Here you already see we use the PF CLI, so the Bot Framework CLI, to use the generated language understanding files that were generated by Bot Framework Composer, and to ship it to Lewis to train it, all the different ones. And then in our next step, we're actually going to publish Lewis via a PowerShell script. Second part, after Lewis, we want to publish our Q&A, send all the knowledge base information, and then the third part is generating an orchestrator model, which is very important to have a good combination between your Lewis and your Q&A models. After that, we're just generating an archive, and we publish that archive to our generated.zip file. So with this, our Lewis model is trained, our Q&A model is trained. Now the last part is training, is publishing the bot on itself. So if you go back, we have build and deploy.NET Web Apps. And if you go down, we do a build the bot, we publish the build artifacts, and here we deploy the Azure Web App, and we configure it with some parameters. In this case, the Microsoft App ID, app passwords, Lewis endpoint, Lewis authoring endpoint, the region, the environment, the default language, and so on, Lewis name, and the different app IDs that needed for this. So there's a bunch of parameters that needs to be configured. Now, once this is all done, normally you don't need to touch these YAML scripts, and is it only the first one, the build and deploy script. Now, once that you have that, if you go to pipelines, you can say I want to create a new pipeline from an existing YAML script, and then you can just, then you'll have something like this. So it will create a pipeline, and each time, depending on, let's open here our YAML script again. We see here trigger now as production, but you could have different ones between your environments. So in this case, we have a dev environment, which has a separate build and deploy YAML branch from. Okay, so it can be different depending on the different repositories that you have. And that's one thing I wanted to share concerning what we have here. So we have the Microsoft provided these scripts to be able to automatically do deployment of your bot, which is perfectly working if you have one environment. Now with a CI/CD environment, while you might have a dev and acceptance and a production environment, depending on your use case. Personally, I think it's always good to have at least a separator between dev and production, so you can also play around with new things and you don't crash your production, so it's more stable. Now, because of working with pipelines here, we do not really have releases. So this is something I'm still working on. It's something that I will be sharing with the community soon. Once it's up and running. So then the idea would be that you have a pipeline that does all the checks and will do the builds and see if everything is in order. And then you will have a release pipeline where you can say now it automatically goes to dev, and when you say okay, it's ready to go to production, you can just push it to there. So I hope this gives you a bit of an overview of what is actually possible with Bot Framework Composer, bringing it first, getting your idea of what you want to build, getting your infrastructure as code, which was already shared in my slides, that you can perfectly reuse. And then, of course, once your bot is there, to set up the full pipeline from dev to production. As I said, it's still a work in progress also on my side to finish that up and make it available for the community. So keep on following me on Twitter. It's @Sammy Deprez, or just like my GitHub page, and you for sure get an update once it's there. So thanks for joining this session. I hope you enjoyed it, and enjoy the rest of your day with more awesome sessions coming up.
All right, that was an absolutely amazing session by Sammy, where you learn how you can go ahead and get started with bot, not only get started, but also take it to the production with pipelines and all. So unfortunately, we won't be able to take the questions. As I said in the very beginning of the session, that it was a recorded session, but I see many people joining in. Hi, Andrew, thanks for joining in. Andy says it was a nice session. Then people are joining from Nigeria. Ganesh, thanks for joining once again. And let's see if we have many more people joining. So thanks everyone who is joining. A quick and gentle reminder that we have the contest going on. Please feel free to go ahead and participate in the contest. There are 3 contests. The first contest is whenever you go ahead and drop a comment in the chats, more specifically when you ask a question to the speaker or share your thoughts for our session, please use the hashtag Cloud Summit without any space between Cloud and Summit. And towards the end of first half of day 3, we're gonna pick winners from the comments. And also we have the contest going on for Twitter and LinkedIn. So take a screen grab or a selfie or be creative in any way. Put it on social media, tag us at C# Live, both on Twitter and on LinkedIn, using the hashtag Cloud Summit, and we will pick the winner towards the end of the day. So until now, we have had 2 sessions. The first session was by Ambarish that talked about how you can use uh, Azure Custom Vision Services. Absolutely amazing. You need to write any single line of code. Everything is done. So if you are a developer but not an AI developer, or if you are not into data science, you can go ahead and get started using Azure Custom Vision. And the second session was in depth by Sammy, who was a Microsoft AI MVP, where he did show you on how you can use, how you can go ahead and build bots from idea till to the deployment. So, hello everyone. Thanks for joining in. Please don't put the hashtag itself. Share us your location from where you're joining. Right? It's always very interesting. Just the hashtag do not count as the valid entry. Having said that, our next session is by Javier. Javier is going to talk about introduction to Azure SQL. And if you're someone who's, if you have been following the organizers of the event, that is C# Corner, in the first quarter, that is the first quarter of this year, in the January, we had a SQL Server virtual conference that was 2 days dedicated just on SQL. And there we had many amazing sessions. So we have one speaker from that event, that is Javier. Javier is going to talk about introduction to Azure SQL. All right, so we have see people joining us from Noida. That's absolutely amazing. Then we have people joining us from Madrid. That is great. Hi everyone. J Star is joining us from Beachside. That's great. So welcome back, everyone. This is day 3 of Cloud Summit 2021. The following session will be also be recorded, so I'm really sorry we won't be able to take questions towards the end of the session. But please feel free to share your thoughts about Azure SQL databases in the comments. And I see, all right, people are joining us from South Africa. People are joining us from Bangalore. Then we have people from Hyderabad, Pune. So the next session is on introduction to Azure SQL by Javier. So enjoy the next 30 minutes on how you can get started with Azure SQL if you're someone who's very new.
Good morning, good evening, good afternoon, and welcome to Cloud Summit 2021. It's a pleasure for me to be here today presenting in this great conference. Thank you so much to the organizing team and the sponsors to make this kind of event possible for all the community. Today, we will have a quick introduction to Azure SQL. We will see all the different flavors that we can have in Azure of the database engine that we all use and love. A little bit about myself. My name is Javier Villegas. I am from Buenos Aires, Argentina. I work as an IT director in DBA and BI services at MSC. I've been working with SQL Server for over 20 years. I am Microsoft MVP in the data platform category since 2016. I am Microsoft certified trainer, and I'm also member of the board of advisor of the Azure Data Tech community. I also define myself as a technical speaker in where I go to all the events that I'm invited to talk about SQL and Azure SQL. On the left side of the screen, you have all my contact information, email address, LinkedIn, Twitter, and my blog. Feel free to reach me if you have any questions in regard to this presentation, or if you just only want to connect. So let's start. This is how I would like to picture Azure SQL, right? This is this new umbrella that Microsoft output just to group all the SQL offering in Azure. We will see three main components plus one which was added recently. The first one is Azure Virtual Machines. This is basically what Microsoft called infrastructure as a service. It's a virtual machine pre-configured in where we can run SQL Server. The same SQL Server version that we've been using forever, right? This is quite interesting because from the Azure portal, you can go there and select from the gallery any combination between operating system, SQL Server version, and edition. You know that since SQL Server 2017, we can run SQL Server in Linux, right? So we can also choose whether we use Windows or Linux, whether we use SQL Server 2014, 17, 16, 19, Standard Edition, Enterprise Edition, the one we need. What it is really interesting is that if we choose one of these predefined images from the galleries, we have certain best practices regarding to SQL Server already pre-configured. Like, for example, how you distribute the data file, the log files, the location of the 10DB, several things. It's important to mention that this offering infrastructure as a service is something that is quite similar to what we've been doing today on premise, right? We have to handle the infrastructure behind SQL Server. So we also have to administer the operating system and the VM. With that, if you need to apply a patch to your Windows Server, to your Linux, this is something that you have to take care of. If you have to apply a patch to SQL Server, right, it's also something that you have to take care of. If you need to set up, for example, authentication, Windows authentication, or Azure logins, right? You also have to set up your own virtual machine, run Active Directory, etc., etc., etc. If you need to set up high availability and disaster recovery, you have to create the window cluster with an additional virtual machine, configure the clustering, configure the availability group, do the whole thing, etc. So this is something that we've been doing today. Also, if we need to take care of doing the backups, right? This is something that we need to take care ourselves. Nowadays, Microsoft is also trying to help us with all these tasks that we need to do in order to maintain the environment, like the backups and high availability, maybe doing some of this point easier from the Azure portal, right? But again, this is something that we have to control. We have to take ownership, right? And the beauty of this option is that since it is the same SQL Server version that we have and we've been working on, right? A migration from our on-premise environment to an Azure virtual machine is extremely easy, right? Because it is the same SQL Server version. Then we have the other option, which is actually two options which are under the category of platform as a service. What is platform as a service? Well, Microsoft provides us with a SQL Server endpoint in where we just connect to that endpoint and we don't have to worry about the infrastructure behind the scene. We don't need to worry about the host, if it is Windows, if it is if there is a missing patch, nothing, right? This is platform as a service. So we connect to the SQL Server. And all those things that I mentioned before, like, for example, backups, patching, high availability, disaster recovery, those tasks are covered by the service itself, right? We don't have to worry about doing those kind of things because it's part of the service. It's really, really a good option, right? And let's describe the two offerings within the platform as a service offering. First one is managed instance. Managed instance is something that we can define as almost 100% compatible with SQL Server, right? But again, as a service, right? When I said almost 100% compatible, we can say that all the features that we've been using from SQL Server, like, for example, replication, CDC, service broker, all the T-SQL that we know, of course, triggers, store procedures, SQL Server mail, everything that we know is there. There are only a couple of things that are not fully implemented, but beside that is, again, a great solution for hosting our SQL Server application, our SQL Server databases, right? Without any big re-engineering or of the application itself, right? So this is managed instance, focused to be a replacement of our SQL Server virtual machine or our SQL servers on-prem, right? With the benefit that we said before regarding to platform as a service. This is a relatively new service in Azure. Then we have another service which is actually not that new, is Azure SQL Database. And in fact, it was one of the first services that were available in Azure when it was presented many years ago, right? Again, under the concept of platform as a service, without us taking care of patching, high availability, etc., right? We have this offering, which is a little bit different than managed instance. And what is the main difference, and why we have two different flavors here? Well, Azure SQL Database, one of the main characteristics is that everything had to live within the same user database. What do I mean with that? If you have an application which requires the database, and the database has a procedure which is joining tables from different user databases, you cannot use Azure SQL Database as it is, right? Because again, everything, all the objects from my application have to live within the same user database. So if this procedure, which is joining tables from my user database, but it's also joining tables that are in a different user database, well, we cannot do it as it is, right? For that, we have the possibility of having managed instance, which is much more similar than SQL Server, right? So is this a limitation? Definitely not. I mean, just having everything on a user database is not a limitation, it's an important characteristic, and something that we have to consider here is that Azure SQL Database is more targeted to modern application, right? So let's say if we want to come up with some sort of rule to see which one we use, how, when, etc., I will say that the easiest way to do the first step migration is, let's say we have this application running on premise for many years and we want to go to Azure, right? The easiest way to do it is, okay, we come up with a virtual machine with the same SQL Server version that we are using, or maybe the latest one, and we also migrate the SQL Server version. This is going to be the simplest one, right? But right after having the application up and running in this virtual machine, we should start testing and checking the possibility of using this existing application using managed instance, right? The migration from SQL Server to managed instance is as easy as taking a backup and restore it to the managed instance. It's really, really easy. But if, let's say, we have a request to start working on a new project, right? A new development that will require a database engine as a backend, definitely we need to take a look to Azure SQL database, right? Again, if we start writing from scratch, most probably Azure SQL database is the right choice. If we need to migrate something that exists, well, most probably, I mean, virtual machine is the first choice, and then the final home for our application will be managed instance. So here we have some points of each of the offerings, right? Something to review maybe later. But what I would like to focus on is on this difference between infrastructure as a service and platform as a service, and which are the benefit of all this offering in Azure. First of all, we have this concept of business continuity, right? We do have multiple options that allow us to have a highly available environment in Azure, right? In any of the options that we mentioned before. In terms of backups and backups retention, and also backup, let's say, storage, or where do we store those backups that we do, right? Azure gives us the possibility of handling the backups automatically, having a retention of several years, actually, and with the addition of having a copy of those backups in multiple Azure regions. Right? Those are things that are really, really important, because if we're trying to certify any of the ISO certification, well, this is one of the important points that is required, right? How we do the backup, how we retain the backup, and how do we store those backups. Then something really, really important from Azure, and something that, you know, with Azure SQL we can take a lot of advantage, is the scalability, right? We can really easily scale up or scale down any of the three offerings that I mentioned before: virtual machine, managed instance, or Azure SQL database. If we have today this environment running on premise and we need to, let's say, add more memory, or improve the disk performance, or maybe add more processor, well, it's a little bit, it's a complex process in where you know, you have to buy the hardware and you know, physically put it within the server. That could take some time, right? Weeks or months. Well, within Azure, if you need to assign more resources, CPU, memory, disk, to any of the Azure SQL offerings, right, it's a matter of few clicks, right? So easily you can scale up or you can scale down. You have all the security that is part of SQL Server, plus the benefit of the security that we have within Azure. Something really important to mention here is that Microsoft is focusing on Azure SQL with the slogan of "it is just SQL." So all the knowledge that we have on how to write Transact SQL, right? We can use it, we can keep using it with absolutely no problem. So definitely something that I would like to emphasize. Another important thing is this concept of versionless. For managed instance or Azure SQL database, right? There is no version. There is no 2016, 19, 2016. There is no edition enterprise standard, right? It's Azure SQL, period, right? With that, we have this continuity of the Azure SQL environment, so we can also rely on it and work in the future. Something that today, if we need to do a migration from one version to the other, it's a complex process that we need to work with and really do a lot of testing and make sure that everything works completely fine. Well, with that, with no version, right? This process is a little bit more easier. I'm not saying that we don't need to, do anything, but definitely it's easier than what it used to be. Being versionless means that this is static. There is no improvement. There is no new features. Absolutely no. Microsoft put a lot of emphasis on new features in Azure SQL first, right? So we can see new features in Azure SQL database or in managed instance way faster than what we can see it in the on-premise SQL Server version, right? And then we have the monitoring and the intelligent framework that we can have within Azure. So what we can say is that now with this offering, we don't need to deal with hardware contracts. We don't need to worry much about the backups because it's all these things are built in as part of the platform as a service offering high availability, disaster recovery, monitoring, and upgrade. These things are part of the service. If we have an existing application, an existing set of databases that we need to migrate to Azure, Microsoft give us Database Migration Assistant and Azure Database Migration Service, which are, a tool and a service that help us to do different type of migration, online migration or offline migration. So virtual machine, if we focus on these virtual machines, well, these are the points that we really need to consider. Do the right selection through the marketplace, and then if we need to monitor and take care of these virtual machines, this is something that we've been doing forever, taking care of the storage, the CPU, the memory. Those are the things that we need to monitor and take care of, right? So within Azure, within the portal and this framework, definitely is easier. It's really easier and something to really consider. And then, managed instance, as we said, this service that allow us to move our databases simpler, as well as Azure SQL database. So here we have one or the other, and we should set the rule before, right? for migration, managed instance, for new projects or new deployment, Azure SQL databases. So now, we took the decision, we go to Azure SQL, we go to a platform as a service offering. If we consider managed instance, we have two options, right? Which are called tiers: general purpose and business critical. General purpose is, according to Microsoft, is a good fit for most of the business workloads. And if we need additional, lower latency and additional read-only replicas, well, we can also choose business critical. This is based on the B core model, so we have to choose the amount of virtual cores that we have in each of the offering. Azure SQL Database, initially there was a model called DTU, based on DTU, Database Transaction Unit. This is still there, but now Microsoft is also recommending the B core model. And again, we have the general purpose tiers, business critical tier, and there is an additional tier called hyperscale, which is a great fit for big database deployment, right? If we are talking about hundreds of terabytes, definitely hyperscale is the tier that we need to consider. How do we connect to Azure SQL? Well, first of all, to do the creation of the services using the Azure portal. Then, when it is already created, how do we work with? Well, with the tools that we've been using since forever. Management Studio, the new Azure Data Studio, and then, we can use different connectivity options like PowerShell, the CLI for Azure, SQL CMD, and T-SQL, of course, right? So, as a summary, right? Azure SQL is the evolution of the best SQL Server engine in the world, SQL Server. Azure SQL includes virtual machine, managed instance, and databases. And if you remember at the beginning, I also mentioned a fourth component, which is Azure SQL Edge, which is SQL Server or Azure SQL running in ARM devices, like for example, a Raspberry Pi, right? This is a good fit for certain scenarios related to Edge. SQL Server on virtual machine is the best fit for 100% lift and shift. So I have this in premise, I have the same in this virtual machine. Azure SQL Managed Instance is the great power of the database engine with the benefit of platform as a service. And Azure SQL Database based for modern cloud application, right? Let's see quickly this in action. So I have here my Management Studio, and I am connected to my three offerings here: my virtual machine, an Azure SQL database, and a managed instance. So I have, the same user experience that we can have with SQL Server, but with the other offerings. If we go to the portal, right? We go to the main portal, we go to Azure SQL, and these are my existing resources. So if I want to create any new Azure SQL component, I have databases, right? Managed instance or virtual machines. See that, for virtual machines, we have, as I said at the beginning, different combination of platform Windows or Linux, and different SQL Server versions and edition. For example, we have Windows Server running on SQL Server running on Windows Server 2019. Then here we can also see 2017 running on other SQL Server in other Windows versions, right? We have here 2019 running in Red Hat, Ubuntu, or SUSE, right? So definitely we have a bunch of options here. And as I said, if we need to connect, we have Management Studio, we have Azure Data Studio to work and connect to any of these offerings. Again, absolutely no problem. All right, so this was a brief introduction to Azure SQL, right? Another good benefit is that with Azure SQL, you can integrate it with many other Azure services like Data Factory, Cognitive Services, Azure Databricks. All the Azure services are really well connected with Azure SQL. So if your project not only required relational database, but also required any other component related to NoSQL, big data, machine learning, you can easily integrate it in this scenario. Okay, very good. I have a final slide here, just to, if you want to learn more about Azure SQL, I leave you this QR code to go directly to the Microsoft documentation. Everything is well detailed, and the documentation is really great. And with that, we finish this presentation. Again, I have my contact here, so LinkedIn, Twitter, email. Don't doubt to contact me if you have any question regarding to the presentation. And with that, thank you so much. Have a great conference, and we stay in touch. Bye.
All right, that was an absolutely amazing session by Javier on how you can go ahead and get started with Azure SQL. What is it? What are the benefits, and why you should learn Azure SQL and ask your managers to start using Azure SQL. Having said that, I do see some of the comments from the viewers that they've asked some questions. But as I said, this session was recorded, so Javier, the speaker, won't be able to answer it. But I think our next speaker who is joining, the Wolfgang, I see him as a data guru. He may be able to answer some of the questions in the comments, and I bet he can do it. But we'll first let him complete his session. Coming up next is Wolfgang, who's going to talk on data, why you should govern your data. It's a session focused on Azure Purview, and I won't take any more time and invite our next speaker, Wolfgang. Hi, Wolfgang. Welcome to Cloud Summit 2021.
Hi, Simon. Thank you. How are you?
I'm doing great. I'm really excited to have you back once again. I think we did connect in the SQL Server Virtual Conference, right? Or maybe Power Platform.
I'm not sure if both. I can't remember.
Me too. But somewhere we both connected this year, early the first quarter. So how are things at your place?
It's okay. Depending on the pandemic, but it's okay. Yeah. Let's see.
Things are getting better, right?
Yeah.
People are going back to offices. So yeah, I think things are getting better. We'll have to figure out on how we take these events to hybrid. That's next.
Yeah, I'm going to Denmark for the
Wow.
first in-person conference tomorrow. So
In
yeah.
past 2 years almost.
Yeah, 1.5 year, first
Yeah.
one. Mm.
That's great. That's great. So, Wolfgang, today you're going to talk about Azure Purview, but I was just reading the abstract. It looks very exciting. So I won't take much of your time. Please feel free to go ahead and share your screen, and then you can get started.
Yeah, perfect. Thank you. So,
And everyone who's watching, please feel free to ask any questions to Wolfgang in the comments, and we'll take all that towards the end of the session. And yeah. I can see your screen. You're inside
screen.
StreamYard. Once you move away, I'll add it to the stream. Yes, I see your presentation. Yeah, and next 25 minutes is all yours.
Okay, thank you very much, and welcome to Cloud Summit 2021. I'm happy that I'm with you and I'm able to talk about data governance, the data what, and first and foremost, why you should govern your data and why should you think about a solution for cataloging your data, for better knowing your data estate in your company. And I'm Wolfgang. I'm coming from Austria. I'm working and living in Austria. I'm working as a data consultant. And what I see is there's data everywhere. When I just look outside, well, there's data on the red house, there's data on the other house, there's data everywhere I look. And especially when I come around and have a look and I talk with our customers, there is almost too much of data. There is data collected everywhere. There's data collected and transferred from system A to system B. And almost nobody really knows what is happening in my company, what is happening in my network, what is happening with my databases, with my data warehouses, where is that data stored? And what we often find and see, my company, my colleagues, we are building analytic systems, data warehouses, data science applications. And what we really, really see is those data islands. All those data, data pieces, they are there in your company, but they are not connected. So there is maybe one ERP island, there is maybe one CRM island, and there is, I don't know, a web shop island. But all the data that is stored in island 1, 2, or 3, it's very important to have it in your company to be able to analyze that data. But you don't really know, and sometimes those companies, they don't really know what happens in between. Is there a data exchange? Sometimes they know, yes, there is a data exchange, but know what are the connecting pieces, what are the connecting processes, and so on. So what would be really, really important for you to know, if and are there any bridges between your data islands? Are there bridges that look like that one on the picture? So really good built streets and so on? Or are there some, let's take data from there, store it in an Excel file and put it somewhere over there, bridges? So we don't really know if we haven't had a look at all our data. And sometimes it's more like, we know there must be some data of kind customer, for example. We are storing customer, we are processing customer data somewhere in our databases. But we have to look where it is stored, and what would help and what really helps in that case, it would be a data map. Something that would enhance our data estate and something that would catalog and build some sort of map. Yeah, with continents of ERP, with a continent CRM, and we've got bridges between those islands. As you can see here, there are connections between those two. And what is really, really necessary in order to build some kind of data map, we need to collect all the information. And what is really important, don't collect the data as you see it in the picture. So there's many books over there. But if you're looking for a Russian book, maybe we should start here and grab all the books and look for a Russian book. So it's not that easy to find the right information, especially if you're looking for one specific kind of data. That orange piece, you are looking for the customer data. You are looking for the field in your database that contains customer numbers. Or let's talk about legal information like GDPR requirements. You have to delete all your customer data that one customer requested for you to delete it. And you have to look in your data estate, and you have to look for every piece of data, of customer data, that is available somewhere. And if you have no catalog, it's not that easy. And the catalog, well, it needs to be ordered. It needs to have an index. It needs to have some sort of ordering structure, and maybe you need some sort of database, some sort of catalog. Maybe you need some sort of search to be able to find the right book. And I know that picture, so it's easy for me. If I'm looking for a Russian for Dummies book, well, that one is here. So it's really easy if you know how all the pieces, how all the knowledge pieces in your environment, in your enterprise are sorted, are collected, are, well, indexed. So what is needed for us to get away from the library into our data estate? Well, we need something that is called data governance. We need something that is called a data catalog. And what I would like to talk today about is Azure Purview. It's a new service from Microsoft. It's a new service, well, that focuses on data governance. It was introduced in December last year, so 10 months old, and that screenshot is taken from the website. So reimagine data governance. And if you talk about data governance, and if you interview 2 or 3 people, you get, I don't know, 10 pieces of information what they think that data governance is. So it's not that easy to find the right definition and a right definition of data governance. Data governance it includes like cataloging your data, to know where your data is stored, to know who is responsible for your data, to know where the data is stored and transferred to know the processes, what are defined around your data, to know the different permissions, who is able to access the data, and so on and so forth. For Azure Purview, although it's called a data governance service, the initial version, the version we are talking about today, it's a data cataloging solution. So it's a tool where you are able to map your data. And it doesn't matter if the data is on premises or in the cloud. It doesn't really matter if the data is stored in the Azure cloud or in Amazon cloud, for example. And what it does and what it helps is it discovers trusted sources. So what you have to do, and we will see it in the demo, we have to define, okay, that's a SQL server in our environment. And the next step, well, Purview scans that source. It does the technical inventory, plus it does some sort of classification. And the classification can include classifications like that's an email address, that's PII data, so privacy data, that is a custom classification like a customer number. We will see it in the demo. You can build custom classification rules. And you can also, with the help of Azure Purview, understand your data supply chain. So data supply chain, well, it's data is stored here and data is going there. And maybe is data going there. So we have some sort of data lineage. We have processes that take data, store data somewhere, transform data. And that is really important to really understand your data landscape. And last but not least, that's the first 3 things. Those are the technical pieces. But what we really need is we need to include the business. The business context is very important because a table called cust or customer, well, that could be a customer table. But if we add some business context, business glossary terms like that's a customer, that's a supplier, that's whatever, the business is able to work with the data catalog. And as I said, Azure Purview in the current version, it's mainly focusing around the data catalog. So what's inside Azure Purview? Not correct. We start with the outside. We start with the sources. So the sources can be cloud-based. They can be multi-cloud-based and or local. So we can scan a data lake. We can scan databases. We can scan SAP. We can scan data lakes in Amazon and so on. And what is needed? Well, there are scanners. Purview comes with built-in scanners. And those scanners are the connectivity process to the sources. So a scanner in Purview does two things. First, source, it understands the source and it extracts the information, the technical metadata. Like in a database, you've got schema, you've got a table, you've got columns, and so on. You've got views in there. So technical inventory. The scanner does the technical structure. In a data lake, you've got some folder structure, you've got files in there. And that is the first step of a scanner. The next step is the classification. And classification can be done and is done first in an automatic way. So Purview, after it knows the technical structure, like the database structure, the tables, it takes a look at the data in there and tries to apply some classification. Those classification rules, there are 200 something built-in classification rules. Plus, you are able to create your own classification, your custom classification rules, like based on a regular expression, based on a dictionary lookup, in order to get some sort of, I often call it a stamp, that table contains email addresses, that table contains customer data, that table contains, for example, Austrian passport information. There is a system classification rule for that. And with that information, the technical inventory plus the classification rules applied, well, the data map can be built. Because the data map, well, Purview scans not only one source. If you register multiple sources, those pieces can be connected, as you can see here. Purview allows you to build some sort of network, and that is the data map, the ERP continent. And within that continent, we've got cities of data, we've got streets, we've got roads, we've got bridges between those continents. And the result, well, it's the data map. In addition, well, there can be some sort of hierarchy, like in a database, we've got schemas. Within a schema, we've got tables. Within a schema, we've got views. Within a data lake storage account, we've got folders, we've got subfolders, we've got files in there, and so on. So that is really the thing that the data map is focused on. The data catalog, well, it uses the data map. And you can use the data catalog front end to search the data catalog, to have a closer look at the information at your data map and maybe your data lineage and your data supply. And I haven't mentioned the thing that those scanners can also include Azure Data Factory, integration services. So those data transfer and data preparation, data integration tools in order to get some information that data is flowing from here into there, and we've got some information in there. So the data catalog, search your data estate, get to know your data supply chain, plus the ability to add business context. So those business users are able to apply, to work with your data, to edit the information. For example, a data steward, a data expert in a certain area, and to search for all those information. And the data insights, they are built into the Azure Purview Studio. Well, they allow you to have a closer look, how many scans, how many files, how many assets are there in your Purview account. And if there is no built-in scanner for system A, well, there is an option for using an open API, because Azure Purview is built on a. And that Apache Atlas, well, it's the open source data governance software. And the open API based on Apache Atlas, well, it allows us to read data out of the data catalog, the data map, plus to write data into that data catalog. So if there's a system that has no pre-registered scanner in Purview, well, there are inventory systems, there are API calls to put the metadata into your Purview account. And with that, let's start and dive into Purview and see Purview in action. So where is my browser? When I open the Azure portal and I open the section for the Purview accounts, well, in my environment, there's one Purview account, and one might ask, why should I create another Purview account? Just think about, maybe I would like to have some sort of testing, some sort of dev infrastructure. Maybe I would like to have a separated prod infrastructure. And before August 2021, there was a need for separating dev and prod, because whenever you created a Purview account, you either had access or no access. There was no way to separate the different pieces of data. No different continents could be permissions added. So it was either, yes, you can work with Purview or not. So there was a requirement. If you already created a Purview account, and I'm going to switch to that one, there is the Purview Studio. That is the one-stop shop for everything you need to work with Purview. And if you open the Purview Studio, well, you can just select the Purview account and switch to that one. In my Purview account, in my demo account, I've already, as you can see here, I'm going to zoom in a little bit, registered 11 sources and roughly 570 assets are in there. What is an asset? Well, an asset is a piece of data. An asset is a database table. An asset is a file in a data lake. An asset is an Azure Data Factory pipeline. So those are assets. And what we need to start with, well, it's the Register Sources button. So I'm going to go here. And in my demo environment, well, I've already registered 11 sources, as you can see, with having different types like Power BI, Azure Resource Groups, Synapse Analytics, SQL databases, and even an on-premises SQL server. So in order to be able to scan an on-premise SQL server, you need a self-hosted integration runtime. Whenever you've worked with Azure Data Factory, Synapse pipelines, well, the integration runtime, it's the connecting piece to your on-premises data sources. And it's the same technology for Purview to connect to your local SQL, for example. There's a data lake registered and so on. If you want to register a new one, register here and have a look at the list of available scanners. So those scanners are built in Azure, mainly focused on Azure. As I said, it's the data lake storage accounts, Synapse, dedicated pools, MySQL, and so on. But it's not limited to Azure. It's Oracle, SQL Server, Teradata, BigQuery, and Power BI, well, Microsoft again. But there are other services and apps like SAP, Looker, or Irvine to integrate the data, the metadata out of those systems. And creating and registering a source, it's only half of the win, because that is, well, it's more or less a connection string. It's more or less, well, the name of a SQL Server endpoint. If I switch to a SQL Server database in the cloud, edit that source, it's, well, the database name. Nothing special, nothing more. If you want to know and want Purview to know more about what is actually in there, you need to register and configure a scan. And a scan, well, is applied to a source, and a scan does the technical magic. So grabs the structure, does the inventory, plus applies the classification. And if we have a look at one of those databases and one of those already configured scans, well, I've already ran them, assets discovered, classified, and so on. And if I go to the edit scan, well, we need to define what is the database we want to scan. And in the next step, for the database, we can define the scope. Do we want to scan the whole database? In a data lake, for example, you can select or deselect containers, you can select folders, and so on. And for the classification, it's the piece where the scan rule set applies. And the scan rule set, well, it contains the information. What are the classification rules that should be applied on your data? And you can use the system-defined ones, the system default ones, or you can apply custom scan rules. I'm gonna go back and go to the management. So classifications can be available in the system list. There are 200 something, like the Austrian identity card, passport number, and so on. And there can be custom classifications. And in my example, I've added a custom classification, which is called Wolfis Kunden, and Kunden equals customer. So I'm going to look for customer numbers in my data estate. And how does Purview does the search and the classification? Well, you can apply custom classification rules. In my case, I've created a custom one, Wolfis Kunden classification rule, which actually is a regex, regular expression. Like in every field, Purview encounters a regex following the pattern KU for customer or Kunde in German, followed by 4 digits. Well, that should be, and that is, well, a customer. It's my customer, or those are my customers. So that is the classification. And the scan rule sets, that is the combination of what should be scanned and what classification rules should be applied. In order to better understand, let's have a look at a custom classification rule for a data lake storage account. So I'm going to have a look at that one. And what should be scanned? Well, those are the file types. What should be applied? Those are the classification rules. I've only selected 13 of the system ones and my 3 custom ones. So that is the information that you need to configure for your scan. And whenever a scan is done, the list of assets is filled. And the assets, as I said, if I start and head over to an Azure SQL database, well, I'm going to move to that one, the AdventureWorks. I've got a DBO schema, I've got a sales LT, and I open an Azure SQL table. And that is the detailed information of your asset in your data catalog. Properties scanned out of the database plus the schema, all the information that was there. And what is also available, well, it's the context section. What you can do is you can edit that information, and we can add a technical expert. For example, I'm going to add myself in here, and I'm the technical expert. So we define who is the technical expert for that kind of data. But searching or working with a data catalog and actually to know where the data is stored, not the best solution. There is a search, and we can search for customers, for example. And what we get back is the list of assets that contains the search text customers somewhere, maybe in a table name, maybe somewhere in a Power BI data flow name, maybe in a file name because it's stored in the data lake. And that is the list of 22 pieces, 22 assets found. What you can actually do on the left side, you can filter based on the source system. You can filter based on the classification. And as you can see, email address is system 1, EU phone number, US phone number is system 1, EU mobile number, and the DBCC, Wolfis Kunde, sorry, those two, those are custom classifications. And if I want to further narrow down those results, I can just select all the pieces that actually have customers classification applied. Head over to the customer table in the database, and as you can see, there is a classification added. And there is also schema classification, because schema entries, like columns in the table, can also contain classification information, like email addresses, person name, phone numbers, and so on. And that is one of those main things. What is still missing? Well, it's the business approach. It's the business glossary terms that are here. You can define the glossary. You are responsible to apply those glossary terms to your assets. So I'm just gonna go back to the customer, selecting that one, editing, management, and I'm gonna selecting, or that one already has 3 glossary terms applied. Can add another one, the German, which is the business partner, save that one. And that is the way to add metadata, business relevant metadata, which can also be used as filter. Last but not least, we are nearing the end of the presentation. It's the data lineage. I started with the supplier table in an Azure SQL database. Schema information is there, and there is also lineage information in there. And what you can see here, data is flowing out of a file that is stored in an Azure Data Lake storage, transferred and moved by an Azure Data Factory pipeline into a SQL Azure database table, taken by another Azure Data Factory pipeline, and stored into another SQL database. And we can switch the assets. Everything is hyper linked, connected, and so on and so forth. You can even track the information of specific columns all over the data lineage. And the pipeline information, the data supply chain information, well, it's pushed from the source systems, like the Synapse pipelines. If you have run a Synapse pipeline, that lineage status is automatically pushed into Azure Purview. You only have to configure the Azure Purview connection. And with that, we've seen Purview in action. We've seen a crash course into Purview. What are the main pillars? Sources, scans, classifications, data assets, data lineage, and your data catalog search. And with that, I'm at the end of my session, and I hope that you got some kind of feeling how easy it is that you can start to govern your data as of today. And with that, thank you for attending my session.
All right, Wolfgang, that was, if you just go back and look at what I really loved about your session was that pace that you had, right? There's a very good rhythm on every slide and everything that you said. I really loved it. We have a couple of questions, a few questions, and we still have time. So let's start with the, okay, I have to figure it out. It went into the top. Okay, let's start with this one. Okay, Cloud Summit, is clustering method are used in this Azure cloud? I don't know if that makes sense.
I have to answer, I don't know.
Yeah, me too.
Yeah.
I just popped the very first question I saw it. Let's look at this one. To keep on top of data governance issue, any suggestions, best 3 places to check or keep an eye
on? If I understood it correctly, what are the resources to start with data governance, or?
Yeah, some of any resources people would like to always go back and check. All right.
What is a really good thing is the tech community blog from Microsoft. There is a special section for Purview. For data governance itself, there are data governance groups on LinkedIn, for example. And I can share those links on Twitter afterwards. So if you follow me on Twitter, I can share those links afterwards. So LinkedIn is a good resource, and there are good webinars around that topic. And for forgot to mention one really, really important one. Just head over to the Purview studio. There's a huge webinar coming on September 28th. Purview team, it's called Azure Purview Digital Event. So register, tune in, and let's see. Purview is in preview as of today, but there is an event at the end of September. Let's see.
Yeah, I mean, there are a lot of events happening in the month of September. I also see this one a serverless conference happening by Microsoft even towards I think it's September 29, somewhere falls around the same time. Let's see, this one question, it says, what type of data should be stored in metadata?
What type of data? The more you can grab, the more data you have to define your metadata, the more data you find to describe your data, store it there. Especially with the Open API, there's a way of creating properties, there's a way of adding descriptions, everything you need, because in the data catalog, you can search for all those pieces and it's searchable. And it's connected, and you can add your own relationships. So it doesn't really need to have an Azure Data Factory in between. You can add a stored procedure connection hub, for example, an edge between those entries. So all of the metadata you have, and you think that is required and that is, well, can be used afterwards, just try to push it somewhere into your data catalog.
Okay, that makes sense. There's one question. I mean, I don't know. We don't build Azure, so but his question. Let's try to answer this one. Some countries, even my country government, fearing to store their sensitive data in the Azure or any other public clouds. Microsoft has any plan to implement the B2 government to encourage to use cloud? Or maybe let's put it this way: if I have a manager, right? How should I convince my manager or my team leads to go ahead and move to Azure or public cloud?
That's a really good question, and we have and had those discussions in the last few years in Austria. Austria is some kind of oh my God, we are afraid of the cloud. It's getting better, and what I see, we are getting an Azure computing center, data center in Austria, and that is one huge thing where customers say, hey, okay, the data is stored somewhere near our company. It's not stored somewhere, and that is one thing. And the other thing, there is a huge list of certifications. There is a long list of available certifications around the Azure topic, like security audits and so on. So if you just search for Azure security and data privacy certifications, you've got 2 weeks to read all those certifications. So that is more the legal aspect, but what I often mention in customers discussions is the Azure team. Well, I think they know how to handle huge amounts of data. I think they know how to handle privacy of data, and is, not to offend anyone, is your admin team in your company that kind of high level like the Azure team? That is one of, I know it's kind of, contrary and some kind of
it makes sense.
Yeah. But they know how to really run huge instances of data and data centers.
I agree. I definitely agree. I think everyone is moving to clouds. Some people are a little skeptical, but as you said, it's changing with time. So definitely, I think everything will move to cloud. Whatever we have, I think so shouldn't be any problem. Trust it. As you said, they're kind of the admins. Any that was an amazing session, Wolfgang. Any final thing you want to plug in before we move to the next session?
For all the others that joined, enjoy the rest of the conference. And Simon, thanks for everything you do. 11 days of work. Get some rest, and thanks.
All right. Thank you, Wolfgang. Really nice to host you again. And I'll see you some other time. Until then, take good care of yourself. And see you soon. Ta-ra.
See you soon. Bye.
All right, with that absolutely amazing session by Wolfgang, we now move to another session that's focused more on .NET and Azure and time series anomaly detection. We're going to have Marco. Marco is a senior solution architect and a Microsoft Azure MVP. And he says he's not a data scientist in his, no, okay, I messed it up, sorry. So let's, that was his session's abstract. You know, it looks like it's third day and it's day 3 and there's still 8 days to go. Can you believe that? You can already see. All right, so let's welcome our next speaker, Marco. Welcome, Marco. Welcome to Cloud Summit 2021. You are muted.
Sorry. Thanks, Simon. Hello. Hello, everyone, and thanks for having me.
Yeah, welcome to Azure. Welcome to Cloud Summit 2021. We're really excited to have you, Marco. Where are you joining us today from?
I'm from, I live in Pordenone, that is in the northeast of Italy.
Mm-hmm.
So, where I have a solution architect in Vintech, a real company that makes solutions, specifically IoT solution for companies here in Italy.
All right, that sounds great. So I already see you're sharing your screen. I'm going to add it to the stream now. And next 25 minutes is all yours. And everyone who's watching on Learn TV, right? On Learn TV, we do not have a chat option. To visit Azure Summit Live website, you there get an option to chat. So yeah, Wolfgang, next 25 minutes is all yours, and I'll see you towards the end.
Okay, so thank you, everyone. Thanks for being here in this session. We will speak time series anomaly detection with Azure and .NET, and this is part 1. And this is part 1 because we will have a second session on September 23rd, and we will go deeper. But I told you next at the end of the session. So I am Parenzan. As I said, I come from Italy, from Pordenone. I'm a solution architect. I have a community here in Pordenone where we speak about these kind of topics. I am an Azure MVP, and these are my profile if you want to contact me after this session. So Simon read in my abstract that I'm not a data scientist. Yes, this is true because I am more a .NET developer. I am an IoT developer because this is what I do on a daily basis. I like to say that I am a one-man band. Obviously, I am a company. I am in a company, and I have a lot of colleagues and with a lot of skills. But sometimes you find alone on working on some topics. Or yes, I have also a background of an individual professional. So my mind comes from one-man band, where you have to handle some topics that you are not very comfortable. For example, data science. Data science is obviously a current topic for these days, and we have to work with. So my comfort zone is mainly .NET. So all my research is about how can I handle these topics with .NET if we can, obviously. So let's introduce a scenario where I have this situation. And the typical scenario where I have this need is an IoT scenario. Things about IoT, things about temperatures. Yes, if you make some work with Arduino, with Raspberry Pi, and you work with some sensor, you play always with temperature. But temperature is a real measure that you need, that you work with on the field. For example, if you speak about real industrial real industrial session, industrial fridges in which you monitor temperature. About temperature, because you have a condenser where you have to exchange heat, and you have to monitor if the temperature go away from the fridge in the correct way. So again, it's not just a play. Temperature is a correct measure in the IoT field. So in the IoT field, we have a device, we have a fridge, we have the temperature sensor, and we collect probably with IoT Hub and with some sort of IoT ingestion, we collect data into a storage for following processing. What do you mean? What do you do with processing IoT data? Well, first and foremost, there is the batch processing. That means you collect and then you process data in the following time. You don't do always real-time processing. Why? Because you don't think that you have real-time need to discover some kind of strange things or outliers that can come in your data. Yes, you have always streaming, but you can start from batch. What you can do with that batch data, you can calculate efficiency if you are consuming correctly energy, if your distribution of energy consumption, for example. And this is typically a BI, a business intelligence topic, in which you present a report with your graph and you see the trend. But what about anomalies? Anomalies is something that goes outside the trend. Something that has to be distinguished from the normal trend. Yes, visually you can understand that there is an anomaly, but how can an algorithm recognize automatically that there is some outlier in the topic? And so this is all about anomaly detection. Anomaly detection in time series. That means events that are sequenced in time. So events that are ordered in time and have to be considered as event ordered, because without ordering you cannot consider this. Anomaly detection of a time series make assumption that there is probably the outlier. So the anomaly is something that is very rare. So you can distinguish because it's a value that comes outside from the normal trends, and that is very distant, very far from the normal trends. And this is how anomaly detection in time series works. Why we have to use data science? Because the threshold anomalies, that means a level, using a level upper or under that level distinguish, like for example this second graph. It's not every time this way, because if you look at the first graph that you look here, you see that the thresholds are continuously different, but is that we can say the percentage, we can say the ratio between the normal and the outlier that becomes the anomaly. But this is not just one value over. This value changes every time. And this is why we have to use other algorithms rather than something about threshold. So our topic is how do we implement the process of working with that data to understand the outliers. Again, as I told you, I'm not a BI analyst, I'm not a data analyst, I'm a .NET developer, and we can say we are alone. Thinks that this kind of project is inside an IoT enablement project where there is no specific focus on that data. In general, there is no specific finance to find analysis. You spend all the money to implement the ingestion architecture, and then you say, okay, next you have to implement some logic on that data. And in your team, there is no resources about that. So I'm a data developer, and I have to understand if the anomaly are present. And so all my journey has become, how can I become a data scientist with my comfort zone? So let's discover which are the pillars of a typical data science and modern data scientist. First, Spark. Spark is an engine, is an open source engine, is a cluster management platform that allows to implement batch processing, real-time processing that scales, because it can work on few data, it can work with big data, so gigabyte, terabytes of data in a scaling and elastic way. So when you work with Spark, you find a couple of scenarios: batch processing and notebooks processing. Batch processing means you create a script, you create a program that you run on Spark. You load the data, the Spark works with the data, and then you obtain your data. As there are notebooks. Notebooks are a tool, an interactive tool, where you can write code. You can write code on the Spark cluster, and then you obtain intermediate data. And you can change your code as you are writing. So you are experimenting, sketching code until you find what you wanted to do, what you wanted to find. So these are two important tools. Overall, notebooks experience is very common. In fact, you have the Jupyter tool, that is the notebook implementation in this web-oriented, data science-oriented world. And then there is obviously Python. There is also Python. Why Python? Because it's simple to start. It is open source. It has a lot of data science tools on that, and so in university and companies, it's quite simple for that to adopt Python. Remember one thing about Python. Yes, when you speak about TensorFlows, PyTorch, you think it's Python. No, there is a library behind that. That is a native library. So the algorithm is not implemented immediately in Python, but is native code, C code, and then you call it from Python. The same way is Spark. Spark is written in Java, so there is a bridge between Python and Spark. So that Python can speak with Spark through Java. And the same is Jupyter. Jupyter is not written, is a web application, is not written in Python, it is written in Java. And this means that also here there is another bridge that is called kernel, that allows Python to speak with Jupyter. So this is the scope. This is the background where typical data scientists work. So let's discover which are the tools that we as .NET developer have in our toolbox and we can use. First, in the data science scenario, you have two specific main differentiation: supervised and unsupervised machine learning. So unsupervised machine learning means no labeling, because me as a developer, not a data scientist, not a data engineer, I don't spend time to label the data to understand which is true, which is false, to train my algorithm. I want something automatic. And that's why there are some algorithms. One of these is spectral residual CNN, convolutional neural network, that are implemented, and this specifically was implemented by Microsoft itself, that it works like an automatic training tool. So you as a developer, you don't need to train the algorithm. It trains itself with the data you give to the tool. And this is good because we want to spend the time to work, not specifically to train and then just to work. And this is good for us as developers. So let's speak about specifically the .NET Toolbox and what .NET gives for you as a data scientist. First and foremost, ML.NET. ML.NET is a library like PyTorch, like TensorFlow, with which you can run data science algorithm, machine learning algorithms natively on .NET. You install in your application NuGet packages, and then you can implement this. In fact, for example, in this are all the tools, all the interfaces, all the tools that .NET implements. You see, okay, sorry, the arrow is moved. You see that here we have anomaly detection. So in ML.NET is not only a platform to implement ML algorithm, but you have directly an algorithm, that's algorithm SRCNN already implemented. And then you can already use it in your application. So ML.NET is a good library to implement anomaly detection. And then you have .NET Interactive. .NET Interactive is the support from the .NET framework, from .NET as a scripting to support Jupyter and Visual Studio Code to implement the notebook experience. And so if you install .NET Interactive, you can have a C# kernel inside Jupyter, or you can use notebooks in Visual Studio Code, writing in C#, and also you can write in F# or in PowerShell, for example, PowerShell core. And this is really, really great. And then you have .NET for Apache Spark, that is the same binding that Python has to write code that runs on Spark. And so you write in .NET Core, and this is great. You don't have to learn Python to write code for Spark. And that code can be run not only on your own cluster or on your machine, but you can also run on Synapse, for example, or, for example, on Databricks. And this is very great. And then there is the Azure Toolbox. What Azure gives us to support time series anomaly detection. Time series anomaly detection, the algorithm that we've seen, for example, the ML.NET code that you can write, can be implemented and hosted in Azure Function. Azure Function is a good way to implement anomaly detection that receive the last sample, the time series to process and to understand which are the outliers of that. Then there are cognitive services in which you have different areas, because you have custom vision, you have speech, but also you have a decision area where there is the anomaly detector. The anomaly detector is an out-of-the-box service, is a SaaS service in which you call a REST API, you send the data, and you obtain the output. You don't have to teach anything. You don't have to configure anything. You have just to configure, you prepare a REST request and then obtain a response. Then you have Azure Synapse. Azure Synapse has included inside it has Spark, so you can host your Spark cluster under Synapse, and then you can also write Python .NET notebooks inside Synapse. This is very great. And then you have Azure Data Explorer. Azure Data Explorer is specifically a platform to manage time series. And on time, and you have a custom language that is custom, in which you have specific language features that allow you to understand if there are outliers in that time series. So you can have a specific service like Data Explorer, or if you want, because you are a business intelligence-based skill, you can also use, again, Synapse. Okay, as we will have a more deeper session on next week on the 23rd, let's look at two fast demos for this session. The first one is this one. This is .NET Code, .NET Core code inside Visual Studio, in which you have what? I have a package that you see, it is Azure AI Anomaly Detector. Okay, so you write the console application, or then, as I told you, you can wrap this code inside an Azure function, for example, and you can you just add these few lines of code. You create a service instance of anomaly detector inside your Azure subscription. You obtain an endpoint and a key. You have your CSV file, which you read as a CSV file. You instantiate your client to the service, and then you can have your processing. Let's look at entire detect sample. So you create a request in which you put your points, and then you just have a request, and that's it. One request, one invocation, and then you have your result. This is just a demo code. You can, with this library, you can detect all the outliers of the series, or you can detect the last outlier in the series, because you can think, I have a batch for all the day, give me all the time. I have packages for 15 minutes, half an hour, and you send each half hour. And so you need the last one, and you send incrementally all your invocation. And this is the threshold. Or you can have also the change point, understand where there is a change in your line trend, so you can understand there is a change. Just to look at how it works. Okay, here it is. Prepare the request. I have the points. I have all the points. Just invoke, and then you have your result. Okay, just to demo. Okay, and you have all the time. You have all your sample data. Okay, and then you probably want to represent. I don't have it in this demo, but I will have in the next week. For that, the other demo is this is Visual Studio Code, and you see that I have an IPy notebook. That is a Python notebook, a Jupyter notebook inside Visual Studio Code. And you see that the kernel that is represented is .NET Interactive. What it means that this is C# code, and we can execute some code. Okay, this is how notebook works. You have markdown code that is just text, and you have a line of codes, and you can have a complex line of code about that. Okay, you have tools to represent all of this. Just to show how it works, I clear the output. You see that you can add, for example, a NuGet package. Okay, you see that it is installing, it's downloading from NuGet, the package for Plotly. That is a library that is born in HTML and JavaScript that represent graphs. Okay, download the NuGet using create a random generator, create a functional time series, and then you have chartplot. And this is how data scientist works. It works with notebooks to understand, to explore your data, things that the code that you have looked with the anomaly detector to put inside this notebook. You will see in the next session. But okay, you understand that you can run everything you want that is HTML based inside your notebook and you write in C#. And this is very great. This allows me that I have no Python knowledge, I have no time to spend to learn a new language. I use my C# code, I use my C# skill to write this kind of code. And that's it. This is what I wanted to do. So understand the message is that the .NET ecosystem in data science world is completing. So it is not behind, is far from. No. .NET is ready to work 360 degrees to cover all the topics. Things that C# is Pythonizing since C#7 to work to have all the simple syntax that Python users love. Things that you can host your .NET code on the Spark. Think that you experiment your .NET code inside .NET Interactive. And think that you can host all this code in Azure because you have many services that can run this code to make you data science. So that's it. That was my objective, to create an overview about the .NET, to tell you that .NET is a language that is ready for the data scientists. I invite you the next week on September 23rd to look at part 2, sorry, not part 1, to look at more complete demo in which you will see ML.NET, Azure Function Hosting, ML.NET, and Azure Cognitive Services, and all that code hosted under Synapse and in Azure Explorer. Thank you.
All right, Marco, I think that was a very crisp presentation, I think, right? And I think people have to come on September 23 to see all the hands-on demo, right? All that you have said today. Yeah, so any final thing before we move to the next session?
Again, I like to say that .NET is really a good environment, and so C# is a great language for data science. We have a very impedance mismatch between data scientist and developer, and there is no more impedance, because as you can write Azure code in Python, you can make good data science code in C#.
That makes sense. That's promising something, right? If you can do data science C#, I see ML.NET, right? People have been using a lot these days, right? Community has been very active around ML.NET. Yeah, so Marco, really excited to see your session on September 23 at 7:30 a.m. Eastern Time Zone. Until then, take good care of yourself. We'll see you then, and yeah, have a nice day ahead, and I'll see you soon.
Okay.
Thank you, Marco. Bye. Take care.
Thank you, Simon. Thank you, everyone. Bye.
All right, with that session by Marco, we now move to our next session. Next session is on Azure SQL. I'm just wondering that this is the third SQL session that we are having. There's so many SQL sessions. I believe any event that we do, I think we at C# Corner, we do like 21 conferences in 2021, and we do live shows every day. And I say that we stream 8 days in a week. SQL is something that people really love. It's no doubt we also have Cosmos DB sessions in the summit, but I don't know, people really like to tune into SQL sessions. So the next session is by Silvano. Silvano is a principal program manager at Microsoft. He's going to talk about increased Azure SQL application resiliency with configurable Teddy logic. And before, you know what? I have a book written by co-authored by Silvano. I thought of reading bio from his book, but I cannot read it. It's so big. I'll let him introduce himself. So without any further ado, let's invite Silvano to Cloud Summit 2021. Hi, Silvano. Welcome to Cloud Summit 2021.
Hi, Simon. Nice to meet you. And how are you?
I'm doing great, Silvano. From where you're joining us today from?
I'm joining from just outside of Milan, Italy. And yeah, as you said, I'm a program manager within the Azure SQL team. And although my team is mainly based in Redmond, I'm here in Europe mostly because I can connect more directly with our customers and take part of their big projects on Azure SQL.
Yeah, to be honest, I did think that you're based out of US because when I was looking at on what time to give you this session, I was like, no, Silvano is from US because all your colleagues, right, we have from there. So I was like, then we figure out, no, you're from Europe somewhere. So thank you so much, Silvano, for accepting the invitation. I'm really excited for your session about Azure SQL. And people are always excited to learn Azure SQL. That is what I have learned from this community, that people really want to learn Azure SQL. So I have your screen being shared. Right, your inside streamer. Once you move to your presentation, I'm going to add it. Yes, everybody can see your screen. Next 30 minutes is all yours.
Perfect. Thanks a lot. And so first of all, good afternoon, good evening, or good morning, depending on where you are when you're watching this. Yeah, my name is Silvano. I'm a program manager in Azure SQL, and I'm focusing primarily around the developer experience of application developers writing application against Azure SQL. So this particular talk will be more focused on kind of code development rather than kind of query processing or kind of other fancy stuff that Azure SQL can do on the server side, right? So we will focus on how to write code properly to deal with things like transient errors and issues that can happen while we are running our applications in a distributed fashion within a cloud provider, right? This actually was a problem also in the good old on-prem space for certain kind of mission critical solutions built on top of very expensive hardware and software. But nowadays in the cloud, we will see why this is becoming more and more relevant. And that's why we introduced the concept of configurable retry logic in our Azure SQL client drivers. For now, you will see that on the SQL client, so on the .NET client that we have, specifically Microsoft.data.SQL client. But the idea is to expand this across all our client drivers portfolio to make sure that out of the box you can configure this new capability and make your applications more reliable. So we will take a look at how to do that, some kind of use cases and scenario, and a lot of demos over the next 25 to 30 minutes. Okay. So what are these transient issues that can happen? Well, these issues can happen at different levels, right? It can be a hardware or software failure within the cloud platform itself, can be a networking glimpse, can be your own application, which is busy processing other stuff and cannot accept new commands and new requests anymore, right? So originally, applications were just failing, right? And so that exception was basically logged somewhere and so on. But nowadays, if we want to make our applications more reliable, we need to consider some behaviors within the application that can deal with these capabilities. And just a reminder, Azure SQL, the different flavors of Azure SQL have kind of architecture behind the scenes that are designed to maintain this kind of high availability. And in order to maintain high availability, they need to, for example, reconfigure servers or fail over between nodes and react, to these planned or unplanned situations. Can be a maintenance where we are rolling out a new feature, or can be, as I was saying, hardware failures that happened somewhere. And those reconfigurations are typically happening in few seconds. Usually, you can see, the average is 2 seconds for failover time in Azure SQL, up to 8 seconds. There can be some kind of longer tails that can happen, but This is on average what we see on the platform, right? And the server is emitting specific error codes. If you click on, we'll see on these links on our documentation, you will see the indication of what type of errors can happen or can be treated as transient. And also a reminder at this other link, you will see what is the underlying architecture of Azure SQL that is maintaining high availability on the different service tiers, right? So again, historically speaking, there's been a proliferation of third-party or external libraries to deal with this transient issues problem, right? So the retry from a let's say architectural perspective, the retry pattern is the approach to use, where basically we are detecting if there is a specific error or exception that is provided by the server, and if that is in a list of errors that we consider retryable, basically we are automatically re-executing the original database operation that was failing after, for some times that are typically configurable, and with a given delay to wait for the server side basically to come back in a good shape and be able to execute the original operation, right? And as I was saying, various libraries and frameworks have been created over the years. Some of the most famous ones are, for example, the Transient fault handling application block from Microsoft Pattern Practices team. Poly is a popular .NET open source library here, but also failsafe in Java, for example, Tenacity for Python, and so on. Those are all interesting external libraries. The problem is, developers should have adopted those techniques upfront, right? And the reality is that this is not very frequent, right? A lot of existing apps out there are not implementing any retry logic. And even if you are developing a brand new application, it's hard to pick up what is the right framework, what is the right library to deal with this type of errors, right? So what we've been doing is, we thought, hey, why don't we create a retry logic framework within our own client drivers, and starting from the V3 of Microsoft Data.SQL client, which is the official .NET client for Azure SQL and for SQL Server in general. We started basically to create a framework where developers can developers that have existing apps don't need to change anything, just add a few configurations in the config file that specify how the application should react. And whenever you are opening up a new connection or you're executing a command, those retry logic capabilities will pop up in case there is one of these transient issues that I was referring to. But if you are developing a brand new one, within the SQL client, you also find a bunch of new classes that you can use in your own application logic in order to create those different kind of retry logic profiles, because maybe your application is doing a lot of different interactions with the database. Some interactions maybe are just queries as part of a reporting page, right? So you can easily kind of simply retry them every time you have a kind of something which is malfunctioning. Or those operations may be part of a more complex transaction, right? So you may want to wrap multiple database interactions back and forth, round trips, into a single kind of unit of work that you want to retry all together or fail all together, right? So for now, we have shipped this in SQL client, but we are planning over the next 12 months or such to be able to expand these capabilities to all the other major client drivers like ODBC, JDBC, PyODBC for Python, and so on and so forth, right? So expect more in this area. So let's dig a little bit deeper into what this configurable retry logic means. So basically, this feature is made of three main components. So there is a core API, so a set of classes that basically are defining what are the behaviors? So how can I detect that there is a transient error? How, what should I do in case there is one, right? And the second pillar here is we implemented on top of this core API our own kind of default out-of-the-box retry logic provider, which is within, again, the SQL client bits, and we shipped this with some predefined behaviors, right? So you can think about the most obvious ones, like a fixed interval retry type, right? So there is an error, I'm going to retry this after 2 seconds or 5 seconds, and then after 10 seconds and 15 seconds, and so on and so forth, right? Or for example, an incremental one, where first time I'm going to try after 2 seconds, and then after 8 seconds, and then after 30 seconds, right? And so on and so forth. So we created those behaviors as part of this retry logic provider, which is available out of the box. You can reuse it as is in your own applications. The third pillar is a configurable configuration file schema, right? So because we want developers to be able to introduce this capability of retry, the retry logic without changing their application code, we wanted basically developers to be able to just change, add a configuration file to an existing code base, configure a few attributes, and then the application will retry immediately without, writing down your own retry logic into your app, right? So this is these are the main components. If we look at the core API, again, kind of three main components here. The enumerator class is basically the one that is generating this sequence of time intervals, right? That they depend on a given retry logic. The retry logic itself is basically asking the enumerator, hey, when is the next time I need to re-execute that? And it's basically checking that the max number of retries is not crossed, and so on and so forth. And the higher level one is the retry provider, which is basically you can define a retry logic with a given enumerator and attach this to a connection or a command object within your code. Right, so you can see this diagram below that, which is explaining how it works. So let's start talking about some more practical aspects here, like hey, how can I use this in my existing app, right? So if I have my code base available, I can just add a reference, basically replacing, for example, system.data.sql client or previous version of the Microsoft.data.sql client with the v3. Then you need to create a specific section in your application configuration file. So this is an example, right? In this config sections, I need to add these three config sections first that are pointing to these specific classes within my SQL client library, right? So the SQL configurable retry logic connection, which is the section of my retry logic dedicated to SQL connection, so opening up a new connection and intercepting an error there, or the SQL configurable retry logic command, which is instead the portion of my retry logic kicking in when I'm executing a command and I'm getting a transient error back, right? We also are protecting this particular feature, retry logic, with this app context switch, because we want to make sure that developers are not kind of switching on this feature by mistake, right? And start applying kind of retry logic where it doesn't make sense. So if you want to use it in your config file, you have, depending on .NET Core or full .NET framework, they have a slightly different syntax, but this is the attribute that you need to have app context switch overrides, and the value which is enable retry logic equals true. Right? So once you have this kind of few sections here, you can add two more attributes. One for basically configuring this retry logic on opening up a new connection. And again, you will see you have to specify what type of retry method. This is a fixed retry or as I was saying, you can have an incremental or an exponential one. The maximum number of retries, the delta time between the retries, and eventually a max time where the library will give up retrying on a specific set of errors. Interesting thing, you can also specify your own list of, if you have in your logic a certain type of error, let's say for example a deadlock type of error, which you want to retry and treat it as a transient, you can create a list of error codes here. Those are the SQL Server error codes or Azure SQL error codes with the separated by a comma, and then add your own. Right. So by default we have, if I remember correctly, like 20 error codes that we are considering as a SQL team retryable, right? But now you can add your own if you think again from your logic you want to get more. The SQL command one is very similar, with the addition of you can add this regular expression here, which is basically telling the library what are the authorized SQL condition where you want to basically kick in this retry logic. Right. In this case, for example, the syntax is quite simple. Is only retrying commands that contains a select in the command text. Right. But you can put here whatever you want. You can create even more complex regular expressions that are basically telling the library where you want to retry a certain operation or not. So what are the retry logic attributes? Again, I just briefly mentioned some of them, but you can imagine those are pretty self-explaining. Number of tries, the delta time between, those retries, min and max time, the list of transient errors, as I was saying, and the name of the methods. By the way, I didn't mention that yet, but in addition to the to the default retry provider that we have baked into the SQL client library, you can create your own. You can create your own .NET assembly and basically inherit those base classes that we have, and then create your own, right? Even exotic or complex one. But you basically can define what are your creator methods to create your retry providers, and then you have to set the retry method name here in your configuration file in order for the library to be able to invoke your own retry provider and your own code. Okay, so let's see it in action now. I think it makes sense to do that. I have this example is also available on my GitHub repo. So if you search S Coriani on GitHub, and then you will see the configurable retry logic repo. I have 3 demos here. Let me move to the introductory one. And here I have the simplest data access application that you can imagine, right? So I'm basically, reading my connection string from an environmental variable. I'm just opening up a connection and creating a SQL command and execute the command, right? Which is returning, the version of my SQL Server or Azure SQL endpoint on the other hand, and basically I'm writing down whatever is returning. I also have here in the code tracing kind of a listener class, which will print out a bunch of interesting information during our demo, right? So if I have this application and my server is returning is basically returning an error, let me try this .NET run, and what's happening here is that, boom, the application is basically broken, right? It's giving me back an exception. Of course, I cannot control, when a transient error is popping up. So what I did was I just closed all the firewall ports here, right? So I'm basically simulating one of these transient errors by closing all the ports, and then I will play with opening and closing to kind of simulate what's going on here. But one important thing here is to see is that the default behavior for any application that doesn't have any retry provider is I'm going to try opening the connection and then I'm going to fail. Okay, so let's see if I have this application config file here pre-created, which is exactly what I showed you previously on the deck, and I'm going to rename it correctly as app.config. Okay, so now the .NET runtime, whenever it's starting this application, it will pick up this configuration file and it will start trying to basically re-execute that connection.open method for maximum 10 times whenever there is a transient error, or again, just my kind of fake transient error here, which is the 4615. Again, the a firewall closed, right? Type of error, which SQL is returning in this case. So I'm going back to my window here, and if I rerun this thing, you will see that now. Okay, now you see this is the retry number 1. So we see the retry logic in action, right? So what it's doing is I'm trying for the first time, for the second time, for the third time. Now, while we are waiting here and retrying, let me open up on this other terminal window my firewall for this particular client IP that I'm running here. Right now, we will see that after a number of retries, the application is now responding correctly, right? So I can see the the SQL Server version. So the application didn't fail, even if for the first 3-4 times the firewall was closed, and now it basically is restarting again. So you can imagine, from an application perspective, she was just waiting for the transient error to basically finish, to stop, and the regular functioning of my SQL Server going back to normal, and then the application will continue to run here forever, right? So this is just an example of what it takes to start from a brand new, from an existing application with no code changes whatsoever. In fact, my code is always here, and I didn't change it. And just adding an application configuration file, few configuration attributes here, and the application will immediately be able to respond to some of transient errors that I'm specifying here in my configuration file. Okay, so this is just one simple demo that I have here. Again, if I'm instead writing a brand new app, I can again use those base classes that I have in my default retry logic provider and start using it to make our applications make my applications more reliable, right? So what I have to do, typically, I'm defining one or more SQL retry logic option instances that are describing what type of retry behaviors my application should have. Then I create one or more SQL retry logic base provider instances. And again, why more? Because within my application logic, I may have different type of behaviors that I want to apply to this type of transient errors, right? So that's why I may need one or actually more, right? And let me go ahead and show you what this means from a code perspective, okay? So I'm now showing this new app folder here where I have again, my app. What I'm doing here is, as I was describing, let me expand this a little bit, make it more readable. So this is the equivalent, as you can see, of that attribute in my config file, right? So where I'm basically specifying, hey, what are my retry logic parameters, the number of retries, what is the gap between retries and so on, and then I'm instantiating this retry logic based provider, right? By creating, in this case, a fixed interval type of retry provider, but I have also all the other types available here. And then I'm just assigning to my connection through the retry logic provider property, I'm assigning the retry logic provider that I just created here, right? And out of the box, my application for the connection.open method will start retrying with the logic that I described here in case there is a transient error. One interesting thing also here, you can see you can intercept an event, right, that is happening every time there is a retry happening, and then you can do things like, for example, logging, log it in your application logs or do whatever you like. But basically, in your code, you can start interacting with the retry logic that you have created, right? So this is how, for a new application, you can leverage this. As I was saying, you can also create a custom retry logic provider. Some examples could be, for example, I don't know, I want to have a pattern of retry operations that is different than what we have in the default provider, right? Or I want to have, the ability within my own code to define for different areas or different situations in my applications completely different behaviors. Well, again, to do that, you just you implement these three interfaces in your code base, and then you can write your own logic, and again, assign the logic to your connections and command instances, and this will work. You will see an example in our documentation available at this link, but I can also quickly show you what it means to create your custom provider. Basically, as you can see here, I have implemented a number of my own custom classes, basically a retry logic one, a provider, and an enumerator, as I was saying, right? So the enumerator, what it's doing is basically just defining. Here it is, creating a new interval mechanism, right? In this case, I'm just returning an interval which is 4 minutes. Kind of meaningless, but just to show how it is. And what I'm doing, I'm implementing this particular interfaces, which is the base enumerator. Same thing for the retry logic, and the retry logic, for example, here I hard-coded the maximum number of attempts. Not a great idea, but again, just to show you that you can create your own logic here, again, implementing this base interface, and then the provider itself here is the one basically applying the logic to a certain number of exception numbers and so on, right? So nothing really super complex here, but just make sure you understand what you're doing when you're creating your custom one. And again, once you have it, the usage is exactly the one of the base provider. You are just creating your custom provider and assign it to connection or to your commands. Okay. So, and again, you will start from that sample in our doc, and that will help you. So again, just to recap, 3 main kind of use cases for the configurable retry logic. If you are creating a brand new cloud native application, please make sure that you consider retry logic as part of your kind of default type of behavior. This is not true for Azure SQL. It's true for every service-to-service interaction in the cloud. Other libraries, client libraries, like, for example, Azure Storage Client Library has retry logic baked in. Service bus has retry logic baked in, and so on and so forth, right? So make sure that you consider this as part of your normal kind of development cycle. If you have existing apps that you're migrating to the cloud, as I was showing you, by just adding an application configuration file and basically leveraging the the latest versions of the SQL client drivers, your applications will automatically become more reliable by reacting to those transient errors. Right? And another scenario which is very, very important, Azure SQL database, sorry, has this serverless service tier, right? Where you can save money by auto-posing an instance that nobody is using for a certain interval of time, right? Now, if you have an application which is which wants to connect to a SQL Server serverless instance that has auto-posed, right? The first operation will always fail because the way you are basically warming up, waking up an auto-posed instance is by trying to connect the first time. Now, with configurable retry logic, you can create your app config file that says, for example, hey, try for couple of seconds, and then if it's failing, wait for the SQL Server serverless database to wake up. So you give it a given amount of kind of retry time, and then the next time that the application will retry, the instance will be up and running. Right. So this is a great simplification again for existing apps that wants to deal with serverless. Okay, so that's all. As a next step, as a kind of recommendation for you, please take a look at the configurable retry logic doc in our public documentations. This is the first link here. There's also a MS Learn course around Azure fundamentals that can help you to learn more about Azure SQL. And in the well-architected framework, which is another area of our Azure documentation, you can take a look at this section called Optimize for Scalability and Reliability and retrieve a lot more interesting information on the subject. Okay, and that's all from my side. Ooh.
Wow, Silvano. I mean, I was looking at the session, everything went over my head. I don't get a lot of stuff. People are talking so great thing, but I think your session covered a lot of demo and how to avoid pitfalls, some of the best practices. So definitely people watching your session now and once we archive it, they'll definitely get to learn a lot. I have a book written by you, right? I have not gone.
Thanks for the free spot.
I've not gone. I'm on chapter 5 now, but this is a more like a hands-on book, right? So I really love this one. Yeah, and I've hosted almost everyone who has co-authored this book, and I say I really love the SQL team. They're very active in their community, and you guys and girls have been doing absolutely amazing job. We have all right. Let me okay. Let me. Okay, we have a question. By Joe is asking, will this configurable retry logic also be available in the MS JDBC driver?
Absolutely. As I was kind of mentioning at the beginning, our goal is to implement the same capability across all our kind of major drivers in our portfolio. So JDBC is actually next in line, as it's very similar from an implementation perspective to the .NET one, right? But we are also working on ODBC, which is still very much used across a bunch of different scenarios. The PHP one, tedious for Node.js. So the idea is make sure that all programming languages and frameworks will be able to leverage the same capability.
All right, that sounds great. So stay tuned. I think it will be released from. I think you also have some monthly newsletters, right, where people can actually go in and follow up.
Correct. Yeah. So there is a Azure SQL a monthly. There's also a live show actually on YouTube, which on a monthly basis is presenting all the news, all the product news, and interesting documentation or samples and so on. So I definitely encourage people to take a look at the Azure SQL account under YouTube. That's probably the most interesting one.
Yeah, I know the Data Expose show, right?
Exactly.
That's one of the very famous one that I see mainly happening every week. So yeah, I think Silvano, that was great. Any final thing you want to plug in before we move to the next session?
Oh, just again, think about your application reliability. It's an important factor in the cloud. It's important that you consider that up front. But even if you can't, we are working to make sure that you can just enable that with some configuration options and make your applications more reliable.
Wow, thank you so much, Silvano. That was absolutely amazing session. We would love to have you back next year or in some other live shows and conferences that we do. Thank you for accepting invitation, and yeah, have a nice day ahead and see you soon.
Thanks, Simon. It would be a pleasure. Bye.
Bye. All right, so here's a quick and very important update that if you're someone who's watching us on Learn TV or on Microsoft Developers YouTube channel, we're gonna drop it from there because they have some other live show schedule. And in fact, Silvano was telling today we have a data exposed episode live show. So yeah, please watch that live show, but don't go away from this Cloud Summit. So we're gonna drop from Learn TV and from Microsoft Developer YouTube channel, but we will come back in after about 2 hours. And then you will be able to hear Kyla Cinnamon giving her keynote and Christopher Harrison talking about static web apps. So in the count of 3, and yeah, please switch to Azure Summit live website where you also get a chat option. On Learn TV, the chat option is not there. I don't know why they didn't enable it. So in the count of 3, 2, 1, we're gonna drop from Learn TV.